that are operated to start the equipment. And while we are operating the PLC, we get the human HMI, human machine interface, wherein we are able to see whether the PLC is running on suitable parameters or not. And then the operators who are running those PLCs and those who are observing the information in the HMI, they take a note of which batch or which ID of intermediate product is being processed. And lately, it has so happened that to make the things somewhat visible across the hierarchy, people have started making WhatsApp groups in which the supervisors are clicking photographs and then they are sharing it in the group. And we have a separate data entry individual who then takes the information from the group and then keeps it in the Excel sheet or Google sheet for historic or for further analysis. Specifically, in case of cold-pressed rolling, the different kinds of data that we see in our plants is that first we have the data that is associated with the immediately casted rolls. So they are these rolls are rolled on top of spool, and then this spool moves from equipment to equipment, including the mills, the crane, and the furnaces. And here, the operators, they have to ensure that the speed at which all of the components of the mill are operating, including the speed, the tension, that has to be maintained. Otherwise, what would happen is that there will be unnecessary joints in the rolled product, which client do not appreciate. And then across the processing period, let us say, which is the once we are rolling from the input coil, how it is being rolled out on another spool, what is the weight, and how much tension has been there across the foil. And at the same time, if there was a breakdown, was it because of usual changeover, or was it because an interruption because it was a breakdown? So there can be a changeover, or maybe the input coil has run out of raw materials, or the thicker coil or the thicker foil, and then towards the output, we might need to either change the spool, or so there are interruptions that can be part of operation. At the same time, there can be interruptions that are breakdown. And then while all of this is happening, there is pressure building to meet the client's requirement. And this is the fact, the way the rolling industry is currently working. And across the operation of our foil rolling, we have to make sure that depending on client's requirement, because there are different clients for this rolling industry and they have different requirements depending on the property of the coil, its thickness, its tensile, its elongation, and all of it is achieved with the help of proper pressure rolling speed. And so we are talking about ensuring very high quality workmanship for every roll that is produced, and uninterrupted supply of the end product. And unfortunately, these two are in shortages. And likewise, in the extrusion mill, what we have is that we have the extrusion press. Interesting fact is that every PLC here, whether it's for extrusion press, or it's for homogenizing furnace, or it's for automatic material handling, or quenching system, all of these, as well as the PLCs that we have discussed for the rolling mills, they are getting the data. The bottleneck is that they are not connected, and that's the first bottleneck. And second is that for those of us who have operated or who have seen the operation of PLCs, we get to see that yes, it does show the reading, but it does not store those readings. And since it does not store any of the reading, even if we want to understand what had been the reason for particular failure in, let's say, our extrusion press, we cannot go back and diagnose it. We have to rely on the input of experts who are there, and human beings or experts, they have limited limited understanding of finding the correlation between different parameters. The reason is that while they might be biased, that the press in this case have been interrupted because of XYZ reason, but the entire reason can be something different. The actual reason can be hidden in the way the motor was moving, one of the motors were moving, or the tension that is there, or maybe the gauge width that has suddenly changed. And for a moment, if we understand, if we assume that people will be able to communicate also effectively, but the time gap that is there in which one of the operator or supervisor communicates it to, let's say, upper management, it's the loss is already done. And since proper storage of data is not there, you cannot go back and then look into what had been the cause for the same. We have observed that while extrusion mills, they operate at quite good efficiency, that is not the case when it comes to die manufacturing, because of one, the most subjective reason is that, and we have heard that when it's about holidays, that is when your work, when the workmanship that is to be done for only for half days, and everyone decides to take a leave, then they would probably finish multiple SKUs in the same day. While at other days, they can intentionally delay it, or even though the delay is not intentional, there is no visibility on where our intermediate product or where our half finished product or maybe raw material is lying, and which equipment is causing bottleneck. Because the only way currently to do is that at beginning of the day, token is generated, that is then passed on to different operators at different equipment, and then the decision makers who have given their word for fulfilling an order, they have to rely on word of few people, that yes, the work is going so fast or something of the sort, but they do not have real-time visibility. And for all the three cases, that is, for all the three cases, whether it's for the rolling mill, or it's for the extrusion, or it's for the die, the challenge is that of manual monitoring. Because even for one equipment, that is, forget about connecting all the equipment together, even for one equipment, the inputs are distributed. So everything that is associated with mill comes and is flushed out from the PLC. So you are able to see the information in the PLC, but you cannot really store it for further purposes. That is the first problem. Then comes the second part, wherein the operators, whatever they are observing with respect to the batch they are processing, they store it on logbooks. This logbook, after a few hours or maybe once in a shift, is clicked or ingested by the supervisor and then forwarded to the reporting authority or the managers. And all of these, they result in first delayed detection as well as delayed delivery. So some of us here might be wondering that at larger plants, we do have some sort of automation or ERP where uh, huge visibility is there. While for medium and small players, upgrading the PLC becomes a cost extensive process, and getting the visibility, it's not there. So while some of the major players also have this problem, we have seen that uh, most of the medium and smaller players are facing this problem. Wherein first, if they have this idea wherein they want to connect all of it, that is all the equipment, there are no vendors, because then it becomes subjective that if you have to connect all of the PLCs, you have to upgrade your PLC. That again is very cost intensive process. And then uh, the people who are connecting it, they are not the one who are providing with software modules for real time analysis and alerts. So, sir, we have taken up this objective, and we have understood this pain point. And with multiple stakeholders, what we did was that we have adapted the systems, the backbone of the system that we had been using in refineries for last. So with the refineries, we have been working for about 6 to 7 years now. So we adapted our technology, and we call it adapt. And the reason why we call it adapt is because it is adapting your existing PLCs and your existing computers into an connected IoT framework. Once they are connected, we then provide our software modules for real-time analysis and alerts. And the promise is that here we are not doing firefighting. We are making data-driven decisions, and with time, as your business scales, the software also evolves. And esteemed audience, we are talking about increasing the efficiency of our processes by 15 to 20%. And that is a scope of huge return on investment. Uh, to put the software in schematic format, assume that we have one PLC or we have multiple PLCs. The modifications that we do is that ideally we have seen the PLCs that are being used at most of the plants. They are pretty old, so we are talking about somewhat a decade old PLC that has got one LAN cable. We simply put a switch that helps to extend the LAN cable port, and whether it's one PLC or multiple, the workflow remains the same. We will put a switch, we will connect our system, that is a computer powered by GPU. So one computer connected to all of your PLCs via a larger switch, and then the data is stored, all of the data. It acts as a small uh, plant-wide network wherein you can log in from your, that is the supervisors or the people who have access. They can there are multiple roles here. People who are operating the PLC, they can log in on the same HMI, and all of the log data that we were feeding in manually or on shades, it is then fed in directly in the system, and the people or the supervisor with access and credential, they can log in from either their tab or their mobile, and they can feed in the information about the observation, much like if there had been an interruption in the process, what was the reason for the interruption, whether it was planned, whether it was part of process, or whether it was unplanned interruption. And likewise, the stakeholders, that is who are, let's say, the directors or the promoters or the people who are at the front of the company fulfilling the client's requirement, they also can log into the same system and they can access all the information. So this in effect is converting all of your. So all you have to do is bring in our system, make some adjustments, and in most efficient manner, the entire existing PLC network gets upgraded to a connected IoT network. And dear audience, here on the screen, you see the screenshot uh, uh, of our software that is running on one of the computers. The special requirement of the computer that comes with the service that we provide is that it has got GPUs, so it is pretty much scalable and runs a lot of computations. Here, it's worth noting that uh, all of the sensors. So here, for ease of understanding, we have considered 3 equipment. Now, all of the equipment here, they are on the same dashboard. That's the first thing. And for every equipment, depending on who logs in, we have the HMI input, or we have the supervisor's input. Uh, uh, Color code as well as the quantification that is there. So what is happening here is that once all of the data is stored centrally, the AI models that we have developed, they keep analyzing in real time.
Ashutosh, please show the presentation along with your presentation. Show the slide where you are speaking.
Are the slides not visible?
No, slides are not visible. You are just talking only. Slides should be visible along with your speech.
Sir, I am presenting. So thank you for interrupting. I mean, I was thinking that the slide is visible.
No. So please run the slides along with your talk. Yeah, run the slides where you are. Yes.
Kindly switch it to presentation mode because we are seeing it.
Yes, sir.
Yeah.
Can you see?
Yes. It's better now. Yes, that's great.
Can you see the changes?
Yes.
Perfect now. Perfect.
Oh, okay. Never mind. Okay. Okay, sir. So I will take 2 minutes, quickly summarize what I have said, and then I will start from the actual slide that is here. Sounds good?
Yes. Okay.
Okay, sir. So
Yeah.
yes, sir. So we discussed about what are the equipment involved in rolling process. So the material moves from all the way from the furnace caster to multiple equipment with the help of cranes, and there are holding and annealing furnaces. So, and the challenge is that so the slide changed. Is it? So you can see.
Slide is changed. Yes.
Okay, sir. So sir,
slide number 4.
Yes, sir. Thank you, sir. So, sir, there are information coming from first the operation of equipment only, wherein we have multiple rollers and everything brought together. Then we have useful information coming from the operator. Then useful information coming from the supervisors. And in the plant, all of this information has to be communicated in real time to ensure that the efficiency of our plant is maximum. And that does not happen in aluminum, the rolling mills also, or extrusion mills, or die manufacturing plants. And sir, we have seen that at some places it's because of the expertise of manpower, while at other places it can be intentional also, because the pressure that people have at the top, the people who are operating the machine, they are not able to gauge it properly. So, sir, here I'm showing the schematic diagram wherein the existing PLCs that are shown on the left. So these PLCs, they remain as they are. when we go ahead with the deployment, we put only switches such that the LAN cables of these PLC, they get extended, and then all of these PLC, they are connected by a larger switch, which in turn is connected to our system. So effectively, plant-wide, uh, the stakeholders, they get a local network wherein the data from equipment is also coming. What used to be a pen and paper based log, there now that log is converted, and now directly information is fed into the system that comes to the central system. The supervisor also, they can feed in the information, whatever they observe about the operation or about interruption, whether it's changeover, whether it's breakdown. They can feed directly in here. The higher stakeholders, that is the directors, promoters, or maybe higher managers, they can log in to see how material is moving. That is at which equipment the material has stalled, and then, because we are storing the data for about 3 months or more, they can go in and analyze that what had been caused, whether it was whether something needs to be improved in overall process, or whether it was specific to individuals training, and then decision can be taken. So can you see the software screen?
Yeah, we are seeing screen
Yes.
number 11 now.
Thank you, sir. Yes, sir. So, sir, here we are seeing the software screen wherein for 3 months or more, whichever we agree, all of the information coming from the plant is stored. And what happens here is that once we start storing the data from your connected plant, we adapt our AI modules that are there. So let's say at t equal to 0, the system is deployed. Then about t equal to 8th week, we will deploy the AI modules also. And the objective that those AI modules serve, sir, is that they quantify individual sensors as well as the equipment independently into what is its health and what is its efficiency. So now you need not worry about it. That is, all of the stakeholder from operator or the supervisor till up, they will be able to see what had been the bottleneck, whether it was because of health or because it was because of efficiency, and then suitable measures can be taken. Moreover, sir, all the equipment that are there. So from what equipment or which material went in, what were the parameters at which it was operated, and what was the information about the material that came out. So you can trace it from the first equipment all the way to last equipment. And in addition to this, the software also, what it does is that it provides information about its own health. That is, what is the average space available, what is the RAM available, so on and so forth. Sir, another important aspect about the software is that it had been evaluated in multiple meetings by the Technical Evaluation Committee of Ministry of Mines. And that is the reason you can see the logo here, along with the name of the software. Once, let's say that once we have observed an anomalous behavior, then the software itself has got provision wherein we can go into, we can either look at the live stream of the data, or historically we can go into the particular time period and then look at what has been the deviation with the analysis tool that is in the software itself. And periodically, so for plant-wide report is generated once in one shift, that is once in 8 hours. Should there be requirement that you want to download the report for your internal review. You can do it whenever you want. So we have put in uh, all of the effort in ideation, development, and perfecting this technology is because uh, we have a vision of developing a general intelligence technology for critical assets, and we have tested it uh, so it is being used at multiple refineries, at multiple aluminum plants, and JNARDC had been quite uh, being one of the trusted users as well as supporters for our technology. Uh, Having said that, we have also served international companies. The technology remains the same. Uh, so our endeavors, that is the softwares that we have developed and the clients that we have served, they have uh, uh, we we have earned the recognition in terms of best startup award uh, twice, once by India Energy Week, then once by FIPI, that is the Federation of Indian Petroleum Industry. We have been awarded the same by KPMG. Uh, from NASSCOM, our technology has got the award for AI game changers in the year 2023-2024. So the value that we are presenting here is that with the existing infrastructure that you have, we have developed the software that integrates it and ensures that the advanced technology comes to a plant, keeps evolving with the most optimized investments. Sir, with this, I'm open for questions that I think will be there. Thank you, sir.
Sir, could you please go to slide number 16?
Yes, sir.
Yeah, can you please explain in detail these use cases, what you have executed in these plants?
Definitely, sir. Definitely. Sir, which industry are you from? I mean, I'm assuming aluminum.
I'm from JSW Steel.
Okay, sir. Okay, so you're from steel. Then it becomes even more interesting. Sir, I would like to add that our technology have been all of our technology has been validated by SAIL also, the technical team of SAIL, uh, so the use case that we served there was of cobalt prevention. Cobalt prevention.
Okay.
Wherein, sir, I will take the liberty of, since I have seen the steel industry and I have seen this technology also, so I will take the liberty of explaining it in your terms. That is, sir, what happens, much like we have seen for aluminum industry, we have multiple equipment. In steel, the speed of execution was quite high. That is, from the furnace all the way to finished goods, the speed was quite high. At the same time, the sensors were there. So we had hot metal detector sensors. Then we had the information coming from all of the rollers that are there. And over a period of time, the main assembly line, it branched into three stands, A, B, and C. So the reason why the sensor and the rollers and the stands are important is because all of these, the data was being recorded, all the data was coming into the PLCs that were there. So we started storing it. That is, we were storing about 700 tags. So here you can think it in terms that every second, or rather at 1/10 of every second, all of these 300 tags were stored. And
sir, actually in our application, we are storing all these data at 5 milliseconds. Because the mill, I'm talking about cold rolling mill, there the speed is so high. So if you do not generate this data at every 5 milliseconds, of any abnormality, any catastrophic condition, we cannot analyze later. So we have to generate this data at every 5 milliseconds.
Great, sir. So, it's good that you already have the data. Now, sir, are you using IBAAS system or something different?
Yeah, we are using IBAAS analyzer. Yeah.
Okay, sir. Yes, sir. So, what happens is that now in your case, what would happen is that IBAAS analyzer, because they also had IBAAS analyzer. So now IBAAS analyzer writes it to a SQL database in real time.
Yeah.
And that is the license that you will have to procure. So once you write it to the another system, in this case, you can think your here you can think that all of the information is coming, and with the IBAAS analyzer, you write the information in the central system, and then on top of it, we will be deploying just the software modules. That is they will do the analysis, and before COBOL is about to happen, on whatever terms we agree, those many seconds before it, the alarms will be given.
For that, we have level 2 automation system. Like whatever sensors we are having at the field, that data is going to the L1. Then this L1 is getting commands from L2 automation system, where we have pre-programmed data for all kind of different grades of steel.
Yes, sir.
It depends, like what is your width, what is your thickness, what is your grade. So based on that, the level 1 system will get the inputs from level 2. So basically, the major player is level 2, which is driving all the show.
Yes, sir. I do agree. I do agree, sir.
So say this that is a solution which can replace this level 2 automation system.
No, sir. That would be very ambitious for me to say. What I'm suggesting is that currently this system sits on top of level 2.
Okay.
So,
what is the role of this system, sir?
Sir, this will okay. Sir, here there are two branches of explanation. Okay, sir. So for the plants who are not as advanced as yours, JSW, so for them it acts as a level 2 system as well as the real-time analytics tool.
Okay.
Now for your system, where we already have sufficient infrastructure for level 1 and level 2 automation. So there, all it would do is that it will help you to avoid possible scenarios of COBOL or other regular failure. Because sir, from our experience, what we understood was that the COBOL was quite frequent.
Yeah, actually, initial stages, this COBOL was very frequent, but after the proper tuning of the equipments and automation system and all the daily loops, now the rate has come down significantly.
Oh, great, sir. Great, sir. So sir, our system will only be there to. So the purpose that our system serves is that for your objective. Let us say if efficiency is your objective or system health is your objective. Only if you have concerns, then the software modules will be adapted accordingly. So let us say when we were deploying it with and working with SAIL, their problem was of COBOL. So the AI framework that we have, they were provided the objectives that we have to give pre-COBOL alarms.
Okay.
And that is how the objective was fulfilled. So in your case, sir, if you are facing some other challenge, maybe fluctuation in one of your motors, or maybe surge is there, or some other interruption. So that objective can be solved very real time. So uninterrupted, what happens is that data come from your L1, L2 to this system that hosts the software, and then real time alerts or insights will be provided that the stakeholders can then go ahead and take suitable actions. All of this, the best part is, all of this is on-premise. So no internet connectivity to keep it secure. This is important.
We have used actually different kind of solution for this, what you have told in your last sentence.
Yes,
We
sir.
have installed IoT sensors, which are basically cloud-based. They use both edge analytics as well as cloud analytics. So the data is going to the AWS cloud. There we have this artificial intelligence and machine learning language, and
Yes,
there
sir.
we have algorithms which basically taking the advantage of this edge analytics and cloud analytics, and based on those inputs, we are generating notification in this what we call it dashboards. So
Yes, sir.
the end user will get, in case of any abnormality, the end user will get notification in form of dashboard, and there it is
Yes,
a
sir.
very generalized kind of report, like what should be the corrective action, preventive action, what should be the root cause of this problem. So before actual breakdown, it is kind of prescriptive maintenance we are using in our plants, sir.
Hmm, hmm.
Like, and
Yes, sir.
these sensors are equipped with the AI and ML.
Oh,
So
great.
the best thing is till date the false negative is 0. So it has never happened that sensor has not given me any notification, but actual breakdown has taken place. So this has never happened. This journey we started in 2020, and
I see.
we have saved more than 11,500 hours. So it has improved our MTBF and MTTR.
Oh, great, sir. Great, sir. Great, sir. Sir, it's really good to hear that. And sir, we are doing the same with the aluminum. So we did it with SAIL. We are doing it with the aluminum industry. And sir, since we are getting most of our revenues from the refineries, so it helps us to do the heavy lifting. At the same time, we are able to serve the medium, small, or larger players uh, with cost-effective solutions. And sir, it's quite good that the solution that you are using, it has not provided false results yet. The same is with us also, but the only difference is that we deploy entire solution customized and on premise. So what it means is that when we are keeping when we are keeping the solution in the cloud, there are two decisions that we have to take. Either it can be customized and specific to only one plant or setup, or it can be generated to multiple plants or setups.
Yeah, we have taken it only for one plant, and it is
Yes,
custom
sir.
for our application only.
Yes, sir.
But
Yes, sir.
the problem is on-premise server is scalability. Suppose if you want to increase your size of system, then it is very difficult in case of local server or on-premise server, because in case of this cloud, scalability is not an issue.
Sir, here you are quite right. You are quite right. The reasoning that we follow is that on-premise, the things that are happening is inference only. So, the solution that is deployed to your on-premise system, it is for inference purposes only, and then we have our expertise in building. What I can say is that hardware efficient models. So we make sure that our models do not, or our AI system do not end up using a lot of computing resources. And when it comes to grading, so it is taken care in the fact that we have very hardware specific AI solutions. And then comes the second aspect of scalability, wherein the models are evolving. So to address that, what we do is that we take the data manually to our development labs or offices, and we update the models. Because of and so the reason why this has happened is because when we are working with refineries, and the first job that we started working with refineries only, and then we worked with Steel Authority of India Limited. So when we worked with refineries, their data handling policies are very stringent. So yes, sir. Now we have put in our engineering resources to make sure that the inferences that is happening on it, that's very hardware optimized. At the same time, we prefer offline upgrades in our AI framework wherever required.
Okay.
So, sir, do you have a requirement that we can serve you with? I know.
Definitely, we have requirements. I'm looking for this solutions from your end. Once this meeting is over, we will have a discussion one-to-one. Then we have so many pain points, operation pain points, where we are searching for some good solutions. So for that, I'll talk to you.
Much appreciated, sir.
Sir, you are in the business of this digital twin also?
Sir, we have made digital twins for distillation columns and different components of distillation columns. We have made it for storage tanks. So yes, sir, we have done it in, and that is where our service to ADNOC, BPCL, IOCL, it comes into picture.
I have seen your slide where you have shown this ADNOC. So this last week only we were discussing with Bosch. So Bosch is doing very big project in ADNOC for this digital twin. So I thought you are also part of that team.
Sir, we are independently. So the first project that you see here now, so real-time visibility and forecast in crude distillation infrastructure. This we are doing independently, sir, and we are doing it for refinery.
Yeah. So we also have such applications in our steel plant. So we would like to talk to you regarding that, and if you can give some solution for that, it would be great.
Much appreciated, sir. So,
okay, sir. Thank you very much.
Thanks, Mr. Pankaj Gupta, for your very interactive discussion. And we will send you this presentation, and you can download from IBAAS website also.
Thank you.
So it's open for discussion. Any more questions?
Yeah, thank you very much, Mr. Ashutosh and Mr. Pankaj Gupta. It was a very interesting discussion. So what I understood, Mr. Ashutosh, from your presentation or this thing is that, is there any of the obsolete systems also, your system is more compatible and will be able to generate the thing, rather than if already somebody is having level 1, level 2, level 3 systems, then it would be a different story. Am I right?
Yes, sir, correct. And it serves, sir, it serves the medium scale players who have. So, sir, from what we have seen is that when we were doing our first deployment, and this is a story that I will take a precious time for. So they were looking at, so they had all of the older system. There were 7 mills. Only 1 mill had the most advanced system that they installed somewhere in 2019 or 2020. That was the most advanced system that they had, and all of the other furnace mills. So their PLC ranged from Kirloskar, analog PLC, all the way till from all the time frames. And they also brought in their vendors. Please provide us with this integrated IoT framework. What happened was that even when the vendor came, they came with their own equipment, all sorts of Wi-Fi routers and modems were there, but their own system was not compatible with their older ones, and that's how their approach was failed for about 2 to 3 years. Then we reached out to them, and yes, sir, while we are not able to integrate the Kirloskar ones that are extremely outdated, but we do pretty good with relatively, let's say, 2 decades old or maybe 1.5 decade old system. So yes, sir, that we can bring on one integrated platform and provide the software solution. So it in a way then acts as an IoT framework with integrated L2 systems.
Yeah. And your system has got a database, or how long your data is kept in your system?
Sir, the software module comes with a database. So
it's
so
an
it is
open
part
source
of
database or any Linux or something open base?
sir, it's not open source database. We prefer like So how do I put it? I prefer it to be. I prefer it to be. So it's our preference, right? But what I can assure you is that, and the reason why I'm saying it's our preference is because uh, we have made a lot of tweaks to make sure that the database that we are using is scalable.
Scalable.
Yes, sir. It's because it has to be scalable because you see, sir, we are talking about hundreds of IO operations happening in real time, and then we have to run our AI modules also and provide you the result.
Yes.
At the same time, one of your supervisors might log in. So yes, sir, the database is trustworthy database, and it's compatible with most of the systems.
It's basically, it's like you interface with the existing legacy systems, and you transport the data from by providing a switch, and then
Yes,
you take the data from it. But how long you were able to store the data in that server in your software?
It depends. The time frame of the time frame for which the data is stored, it depends on the hardware. So the hardware that we provide, so it's a desktop. So fundamentally, it's a desktop, or we go for industrial PC also, depending on whichever people are comfortable with. Once when we were deploying it with one of the MSME aluminum industry, they were quite okay with our industrial PC. That is equally powerful, but it's cheaper. And then depending on the memory it has, so it becomes a factor of memory, sir. True. And then, sir, so yeah, now based on mutual discussion, we provide the timeline. And in one of the systems, you must have seen how much memory is remaining. So that serves as a cue that now is the time you back it up, so that you have all the information in place.
Mm-hmm. But you don't provide a server along with hardware. You don't recommend for your systems to be installed in a server wherein you have the storage, comfortable storage where you can extend the storage and all depending on the need as the data goes.
Sir, we can do it. We can do it, but we do not do it because
cost factor.
Sir, that's a subjective discussion that we can have, but it's doable.
Okay.
Thank you very much.
Hello, Mr. Ashutosh. Can I ask a question?
Yes, please.
Say,
Yes, sir. Please, sir.
Mill in aluminum industry, but the most important area of operation in aluminum smelter is pot room. So yes, all the technology suppliers, they have provided their own devices for controlling the pots of a line about 240 pot or 480 pots like that. Do you have any suggestion to improve the pot room operation or reduce?
Yes, sir. Sorry, sir. I have turned off my video because of some bandwidth issue. Let me see. Yes, sir. So, if I understood your requirement correctly, Bera, sir, the challenge is that, like we were discussing about different PLC, here in the pot room, we have multiple sensors provided by different vendors. And now you have to have visibility or insight from all these sensors at a time so that the efficiency of the pot room can be improved. Correct, sir?
Yeah, that is it. Yeah.
Exactly, sir. Sir, most optimistic answer is yes, sir. It can be done. That is, efficiency of pot room can be improved because fundamentally we have been doing it for different PLCs. What we will need from your end or whoever is facing that issue is that, sir, we need the information about what is the so there are some specific information with respect to the sensors. So what I can suggest is, sir, if it's a pain point, it is a solvable problem. The only place where it's not solvable is because is that if the data recording as well as data transmission, everything is proprietary or encrypted, which is highly unlikely. So in most cases, we have seen that Yes, while it's complicated, there is ethical way of reading the data, and then once the data is read, uh, then it can be integrated and the real-time visibility can be provided.
So already there, because the pods are controlled by micropod control system. So every pod has own data and it is stored, and also it is transmitted to central control room. So from
it
the
can be done, sir. It can be
okay,
done.
yeah, it can be done at control room itself.
Yes, sir. Yes, it can be done.
Okay. Thank you.
With the permission of Maheshwar Saab, can I add something on what you have said? Yeah, Mr. Ashutosh, actually, I'm also from the part room background. So where we have, what microcontroller or part controller or whatever you call that is an intuitive unit, which continuously talks to the PLC or a server. Okay, the PLC collects the data and it sends to, in our case, company where I worked, it used to send to a Unix server. The Unix used to again take the data, process, compile the data, and summarize it and send it to Oracle database.
Oh, fantastic.
Okay, here the main thing what we face a challenge in our part rooms is the noise we call that is the noise in the voltage measurement we do because of the metal movement and the magnetics. There is some noise always there.
Okay, sir.
The least is the better. So there are algorithms built within the PLC itself. When there is a noise in the part, what to do? It does a certain series of steps. When it cannot control by itself in automatic mode, it will say that, sorry, it's a failure, it announces a failure. Then people pick up and manual control and then do it. So here, the thing is that the data is also is very huge because one part line, as Mr. Maheshwar has mentioned, has got 400 parts, 300 parts, 500 parts, like that, depending on the length of the part line. And all these data minimum you can take every data at every 1 minute minimum also you take. So many records are generated. It's a huge thing that's coming. And then another place where it would help in aluminum industry is something called a situation called anode effect in the parts, which is most undesirable. So there are now people are also, every company is working with their own way with AI and ML and all to how to predict that and how to kill it from the beginning itself before the event takes place. So like that, there will be a scope there. So, but I think if you can get in touch with somebody in the pot room area who are working, I'm retired now, I'm at home, so I'm not working anywhere. So it'll be a good area for you to do the improvement, and definitely people will be happy to receive such.
Sir, you and Beras have shown the seed now.
Yeah.
Because now I know. So now I know that the data is not encrypted, and it's going to the Unix server, so data is not proprietary also. So the challenge is that the variation in data, as you rightly put, the variation in data and the volume of data is the challenge. And what can be a better computation problem where we have a lot of data than that? So I'm really happy.
Yeah, but like that, even I personally would also prefer always on-premise server only rather than a cloud.
Yes, sir.
Something like living in our own house or a rented apartment.
We have better control.
Yeah, we have full control.
Exactly.
But we have always, our storage area network SAN is entirely different. So it's like our Oracle RAC type of system setup. It was hardware system sitting on top of the WebLogic server. So the SAN is common. So either whichever database is connected. I mean, if there is in case of for redundancy, we have two databases. One will always connect, other one is in the sync always. So other one takes from that point of view in case of any failure on the one server. So we increase only the SAN area, not the actual
the processing area. So the processing area remains the same. The redundancy part keeps.
We don't have to do the cloning. From the same SAN, both the DBs read. One is active, other one is passive. On top of the application servers.
Yes, sir.
And on the Oracle database, we put again Oracle Business Intelligence also. For analytics, we use that.
So, there had been a time where whatever you use at the backend, Oracle is working.
Yes, sir.
So our objective is also almost the same, that whichever industry you go, Caliche should be at the back. Whether refinery, steel, aluminum. So yes, sir, long way to go, but we are hopeful.
Yeah, true.
Thanks. Any more questions? Mr.
There-
Pradeep Chaudhary, somebody, if any wants more
There are, sir,
questions?
you are, there are, sir,
Okay, we
Yes,
brought a crucial issue of port operation, so you can think of it. And many industry will benefit, maybe entire world will benefit out of it.
Yeah.
sir,
Ashutosh, we invite you to the Jharsuguda conference, which we are holding in September 2026. So please send a paper and you can have the opportunity to meet all the smelter experts over there.
noted, sir.
Okay. Okay. We will
Noted.
send you, our office will send you detail. So any more question, Pradeep Chaudhary or anybody else? Mr. Das or Tejal, hello day. Anybody wants Jagdish?
Yes, I have a question.
Yeah.
Can you hear me?
Yes,
Yes,
yes.
sir.
Jagdish.
Yeah. Do you have any application in the cast house area?
Sir,
Casting area?
Sir, specific to casting, the reason why I did not go specific to casting is because casting and its equipment were taken care when we were working on the integrated integrating the plan. So yes, sir, that is one. So specific to casting, as of today, we do not have a problem. We do not have a solution. We have a solution that integrates. So yeah, fundamentally, if it's with respect to integrating something, or if there is an objective that or specific challenge that you are facing, so that we can address. But as of today, so specific to casting, no, sir, we do not have a solution.
Because cast
So
house
it's-
also has the PLCs and other things. You know, there is a lot of.
Yes, sir. So sir, for like I said, integrating and bringing the data from casting house to one central system wherein health, efficiency, and analysis can be done. This is there. It applies. In addition to this, like sir was saying, for pot room we have a different engineering challenge. So if you have a different engineering challenge from the cast room or casting setup, so that I am afraid that you will have to explain to me, then I can get back to you.
Okay. Okay. All right. Okay. Thank you.
Thanks, everybody. The presentation will be available on IBAAS website, and we will make a list of all the participants, and you can directly contact Ashutosh Kumar for any clarification and thing, and even through IBAAS office can facilitate you. Thank you.
Thank you, sir. Thank you very much.
Thank you very much.
Thanks a lot, everyone.
Thank
Thanks.
you. Happy New Year. Season's
Happy New
greeting.
Year to all. Yeah.
Happy New Year.
Happy New Year.
Happy New Year.
Right. Thanks. See you there.
Hoje a Cariô, hoje estamos na igreja da Oxum e
Only learning.
vamos hoje a Cariô, ao Sério Prata vai